let's start off with the topic on energy. We're going to kick off first with the formulae for mechanical energy. So the first one is none other than work done equal to force times distance. Distance is the distance traveled in the direction of the force. Next is actually the kinetic energy, which is half mv squared. We could also manipulate the expression such that it is in terms of momentum and mass. So in this case, it will be half p squared divided by m. Gravitational potential energy, that is mgh. Later, when you cover the topic in gravitation, then you will learn this formula, which is minus gmm over r. Elastic potential energy, that's actually your spring, which is half kx squared. Later, in our second part of our brief, we'll go into details with this. These are the three other formulas. One is obviously energy. Energy is equal to power multiplied by time. Your power is in watt, energy in joule, and time in second. And your efficiency is the useful power, or the power output divided by the power input multiplied by 100%. Power is equal to force multiplied by speed. So it is equal to force multiplied by the distance traveled divided by the time taken. So basically, it is actually work done divided by time. Okay, let's take a look at the heat energy. For heat energy, let's take a look at the work done by a gas. Work done by a gas is equal to pressure multiplied by the change in volume. So for example, we actually have a sample of gas inside the piston. So the work done by the gas actually forced the piston to move outwards by a distance change in L. So the work done can now be equal to force multiplied by the distance traveled, which is actually change in L. And your force is pressure multiplied by area multiplied by change in L. So area is the cross-sectional area of this piston. So the A multiplied by change in L is in actual fact your change in volume. Next formula that I've learned at O level is Q equal to MC change in T. C is none other than your specific heat capacity. Change in T, the unit can be in Kelvin or degree Celsius. Next set of formula is what you've learned at O level. Q equal to MLF. M is the mass. LF is the specific latent heat of fusion. That is the amount of energy that's required to convert per unit mass of solid to liquid. Q is also equal to MLV. In this case, LV is the specific latent heat of vaporization. That's to convert per unit mass of liquid to gas. Lastly, this is the average kinetic energy of a gas molecule, which is 3/2 kT. Total Ke is 3/2 nKT. This is the formula. This is the energy formula that you will learn later when you go on to ideal gas. Electric potential energy is this formula, something that you learn later as well when you get onto the topic in electrostatics. The last part for energy is actually electrical energy. Work done by a charge is equal to the charge multiplied by the potential difference that the charge has moved across the 2 points. Power is equal to VI, otherwise I squared R IV, and energy is equal to power times time, which means that electrical energy could actually be calculated using VIT or IVT rather. Finally, wave and particle energy. This is something that you will learn when you get on to the topic wave and particle. So in this case, energy is equal to power multiplied by time. Power is in watt, T is in second. But do note that power can be equal to I times A, I times area. I is actually the intensity. That is the amount of energy that could be transferred per unit area. So the unit for intensity is watt per meter squared, while the unit for your area is meter squared. Last but not least, the last formula you look at is to calculate the energy of a photon equal to HF. That's something you learn in the last topic of physics.